Okay, hello everyone. I welcomes to all in our lecture series on Dirac delta function represented as del. In this lecture series, we are going to discuss these topics: introduction to Dirac delta function, representation of Dirac delta function, and applications, properties of Dirac delta function, and their proof with important questions belongs to each and every properties. Then 3D delta function, then integral representation of Dirac delta function and corresponding questions. These topics are very much essential for BTech, BSc, MSc, MTech and various entrance examinations like CUET, CPT, JAM, GATE, NET, TIFR, etc. Okay, let us start to discuss our first topic, introduction to Dirac delta function. To understand what is exactly called as the Dirac delta function, consider a charged particle, suppose proton, moving along positive x-axis direction like this, and this motion is represented by a continuous function fx. Now we are going to apply a electric field at x equal to 0 like this, perpendicular to its path. If the proton will be interacted with this electric field, then it will be deviated sharply along this direction. Okay, same thing I have been written. A large electric force acts on the charged particle for a very short time at x equal to 0. Like a impulse force, due to this impulse force, the motion of the charged particle or the so-called fx sharply deviated or disturbed, or you can say activated at x equal 0 only from its original path, whatever I shown in the animation. This impulse force which is at x equal 0, here we consider as electric field or electric force, you can say. That impulse force can be represented by an impulse function called Dirac delta function del. Okay, in case of one dimension along x-axis, if I'm going to say, then in bracket x we have write. Okay, like this. That means Dirac delta function exists at x equal to 0 as a electric force which deviates the motion of the proton from its original path to this path. Okay, mathematic, or see, delta x, or we can write delta x minus 0. Mathematically, this function delta x can be represented like this. This is most important. That means here delta function or the impulse force exists only at x equal 0. That means effect we can observe at x equal 0. So mathematically it is written as infinite. So here infinite means effect observed. Effect observed or presence of delta function where it is at x equal 0. So delta function exists at x equal 0. Hence we observe the effect or disturbed or disturbance we observed at x equal 0. So here this infinite represents the disturbance or effect which is exist at x equal 0, but that effect is 0 elsewhere if x not equal 0. So mathematically it is written as, for x equal 0 delta function value is infinite. For x not equal 0 except x equal 0, other position if I am going to consider, the effect is not observed or we written 0. Okay, okay, yes. Mathematically the whole dynamics can be written as, here whole dynamics means what, here at x equal to 0 a electric field exists. When the proton came from this point along positive x-axis at x equal 0, it has been deviated. That means function has been deviated due to delta function. So what we have to write, fx interacted with delta x or delta x minus 0. X minus 0 means at origin it is exist, will be value will be f of 0. That means function changed at x equal 0. In this way, in this physical imagination, we can understand this equation. That means any continuous function will be exist delta function, then value will be this much. Same thing I have been written, fx delta x, or fx is a continuous function interacted with a delta function which is at x equal to 0. The value will be f of 0 delta x. Okay. Another important point you have to remember for Dirac delta function, this is always true. That means if I integrate from minus infinity to plus infinity, delta function, the value will be 1. That means delta function exists. That is true. That is always true. That means minus infinity to plus infinity, delta x dx equal to 1. Or you can say 100% probability we have to get that from minus infinity to plus infinity, delta function exists somewhere. In this case, delta function exists at x equal to 0. Right? Now the same situation if we are going to consider at x equal to a. Suppose delta function exists at x equal to a, then it will be here the proton will be interacted with the electric field at x equal to a, and then it will be deviated. So at x equal to a, the delta function exists, means it will be represented as delta x minus the point where it is exist. At a point it is exist, so delta x minus a. Okay, same thing I have been written here. A large force act on the charge particle very short time at x equal to a, like impulse blah blah. Mathematically, what we have to write for this case, delta x minus a will be infinite at x equal to a. That means delta function or impulse force exists. This infinite represents the physical meaning of this infinite, means it exists. The effect is observed or effect is exist. Okay, at x equal to a. Elsewhere it is 0. Here in this case, continuous function, that means motion of the proton will be interacted at x equal to a, so it will be deviated only at x equal to a and undeviated elsewhere. It could not be deviated at these points, only it will deviate at x equal to a. Mathematical, what we can write, function, continuous function f of x delta x minus a will be f of a into delta x minus a. Mistakenly I written this one, this will be written as x minus a. Okay. Okay, then okay, here the two situations we have been discussed, that the impulsive force exists at a particular point. Here x equal to a exists, and in our previous case, function delta function was exist at sharply at x equal to 0. Sometimes delta function exists. It can be found that sometimes impulse force or delta function exists or is is spreaded over a region which is represented by a Gaussian function. How it is? Consider a electric field exists in this region from this point to this point in this region. Okay, the intensity of electric field intensity at this point is maximum. Here you can see the line is thicker and the line is gradually decreases or thinner and thinner towards this side. That means field intensity decreases both the side of this point and exist in between these 2 points or in this region. Okay, so this impulse force or delta function can be represented by a Gaussian function. This is the Gaussian function curve. This is a well-known Gaussian function curve. Okay, so peak intensity maximum at x equal to a and peak intensity gradually decreases both the side of x equal to a. Right, so hence for this case, delta function, if I'm going to consider the property of delta function, that is your minus infinity plus infinity delta x minus del dx should be 1. We can also write this integration limit by segregating minus infinite to, here you can see this function Gaussian function spreaded in this region. Suppose this point is your a minus delta x and this point is your a plus delta x, so obviously this distance is your 2 delta x. Hence the limit will be segregated, that minus infinite to this point, minus infinite to a minus delta x into delta x minus a plus a minus delta x2 from this point to this point, a plus delta x del x into delta x minus a plus, here a plus, it should be a plus. Okay, I'll correct it, a plus del x to infinite delta x minus a dx equal to 0. So obviously this function exists in between these 2 points. So this integration will be valid and these two integration will be cancelled out. So we have to write this one equal to 1. Or we can write, instead of delta x minus a, g, which is nothing but your Gaussian function dx equal to 1. Okay. We know in general the Gaussian function is represented as this one, 1 by sigma root over of 2 pi e to the power x minus a square by 2 sigma square. Here sigma is a constant or the so-called standard deviation. Okay, you just remember as a constant. So this function will be represented as a delta function which is spreaded over a region, or the so-called Gaussian function, that we are going to prove that Gaussian function also can be represented as a delta function. That means if I am going to consider this function and I am going to integrate minus infinity to plus infinity, it has to give the answer 1. That we are going to prove in our next class. Or we can say Gaussian function is the representation of the Dirac delta function. In our next class also we are going to discuss some other different type of functions which can represent the delta function. From today's class, one thing we can conclude that in physics, wherever we found any impulsive force that can be represented by delta function. I'm going to give a simple example, Rutherford experiment. Alpha particle interacted with the gold foil or the nucleus and it is scattered. The scattering happens instantaneously due to impulsive force, and that impulsive force can be represented by delta function. Another beautiful example is your quantum particle, which is represented like this. Okay, so the particle highly localized at the center and the probability of localization reduced both the side. That means it looks like a Gaussian wave function, Gaussian function. That means delta function. So many applications you can found in physics, or you can simply you can say that wherever we interacted with any impulse type of situation, at that time we can use the delta function. Thank you so much for watching this video. Thank you.